So good evening to everyone. Today I'm going to discuss about the kinematic equations by using calculus method. Okay, these kinematic equations we derive three different methods. The first one is algebraic method. Second one is graphical method, and third one is calculus method. Okay, in this session we are going to discuss about the equations of motion by using calculus method. And in this session, I'm going to discuss about the equations of motion the based on the uniform acceleration motion by using calculus method. Okay, we can derive equations one by one in this session. The first one is according to the definition of acceleration is equal to the rate of change of velocity. The rate of change of velocity is called acceleration. We rearrange the equation, a cross multiplication to the condition dv is equal to a into dt. It is taken as equation number 1. Okay, if the body is starting at t is equal to 0 seconds, then the velocity is u, initial velocity. After some time, means the t2 is equal to t seconds. The final velocity is moving with the velocity is v. Okay, these two limits only. In these limits, the integrating equations 1 by using these two limits. Therefore, integral u to v dv is equal to integral 0 to t a into dt. Okay, integral u to v dv, that means here there is no coefficient, but here 1 is there. Okay, integral u into dv, that means final velocity, final limit minus lower limit, that means upper limit minus lower limit is equal to a is common, integral 0 to t into dt. Then v minus u is equal to a into t. Okay, finally the condition v is equal to u plus at. This is the kinematics first equation. In this first equation is also known as velocity time relation, because the first letter in this equation v and the last letter is t. That's why in this equation uh, is also known as velocity time relation. Okay, this is the first equation of motion. The next we derive the second equation. Okay, the definition of velocity is equal to the rate of change of displacement. Can rearrange the equations here. ds is equal to v into dt. ds is equal to v into dt. Okay, from equation of motion, the first one, here v is equal to u plus at. Okay, v is equal to u plus at. In this value substituted here, therefore ds is equal to u plus at into dt. Okay, in integration, the second equation, when the time t1 is equal to 0, the distance traveled by the body is equal to 0. At t is equal to 0 seconds, the distance also 0. If the So after some time, that means the t2 is equal to t seconds, the distance traveled by the body is s. That is, we don't know that the distance only. That's why I will take s only. The integration on the second condition by using these limits, integral s2 s1 to s2 into ds is equal to integral t1 to t2 into vdt. The limits of the distance s1 and s2 are 0 to s. 0 to s into ds is equal to integral 0 to t v dt. Here v means u plus at into dt. Okay, the first one is upper limit minus lower limit. S minus 0 is equal to integral u into t ut plus a into t square by 2. Therefore, S is equal to ut plus half at square. Okay, the first letter is the displacement, the last letter is time. Then only we call the second equation displacement time relation. Displacement time relation. This is the equation number 2 from the equation of motion. The next two we are going to discuss about the third equation only. Third equation of motion. The third equation of motion by the definitions of velocity and acceleration. Then acceleration is equal to the rate of change of velocity. A is equal to dv by dt. Okay, here numerator and denominator we add, we multiply or divided by ds by ds. That means if the ds these two are cancelled, then we'll get the same condition on a is equal to dv by dt. Therefore, a is equal to dv by ds into ds by dt. Here ds by dt is nothing but velocity. That means the rate of change of displacement. Therefore, a is equal to v into dv by ds. Okay, we arrange these equations. A into ds is equal to v into dv. A into ds is equal to v into dv. When the time t is equal to t1 is equal to 0 seconds, the initial velocity is u. The initial velocity is u. The distance traveled by the body s1 is equal to 0 second at 0 meter. After some time, that means t2 is equal to t seconds, the body becomes with the velocity is v. Then s2, the distance traveled by the particle or body is s meter. Okay, this is a third condition. In this third condition, we apply these limits, the following, the two limits only. The integral 0 to s into a into ds is equal to integral u to v dv. Here a is a common. Integral 0 to s into ds is equal to v square minus u square by 2. Here a into s minus 0 is equal to v square minus u square by 2. Therefore, 2as is equal to v square minus u square. So finally the condition is v square is equal to u square plus 2as. Okay, this is the third equation of motion. In this third equation of motion, the first letter is v. That's why velocity and the last letter is a displacement. The velocity displacement relation is the third equation of motion. V square is equal to u square plus 2as. Okay, this is the third equation of motion. And the fourth condition, the distance traveled by the nth body. The distance traveled by the nth body, by the definition of velocity, v is equal to ds by dt. That means the rate of change of displacement is called velocity. Okay, we arrange the equations. ds is equal to v into dt. ds is equal to v into dt. Here v means the equation of motion, first one, u plus at into dt is equal to ds. When the time, then t1 is equal to n minus 1th second. N minus 1th second, the distance traveled is equal to s n minus 1. When the time t is equal to n seconds, then the distance traveled by the object is s nth. Okay, here in this one, fourth condition, ds is equal to u plus at into dt. Okay, these limits, the following two limits are integrating on the both sides of the equation number 4. Therefore, n minus n minus 1 into Sn ds is equal to integral n minus 1 into n u plus at into dt. So that is equal to here Sn minus Sn minus 1 is equal to, the u is the common here, into 1 dt integral of n minus 1 to n plus, here a also common, integral n minus 1 into n into dt. N minus Sn minus 1, that is equal to here 1 into dt means t only. Therefore, u into t n minus 1 into n plus a into t square by 2, the integral n minus 1 into n. Therefore, u into n minus of n minus 1, that means upper limit minus lower limit, plus here 1 by 2 is common, that means a by 2 is common, n square minus of n minus 1 whole square. So that is equal to, okay, here un, okay, un plus u plus a by 2 into n square minus n square plus 2n minus 1. Okay, these two are cancelled to each other. Finally the distance traveled in the second formula, Sn is equal to u plus a by 2 into 2n minus 1. This is the fourth equation of motion by using calculus method in the presence of uniform acceleration motion. Okay, this is the kinematic equations, how to derive the equations by using calculus method. Thank you.